Structural technology is the technology of putting parts and materials together to create supports, containers, shelters, connectors, and functional shapes. The four types of bridges are arch, suspension, cantilever, and beam. An arch bridge is a bridge with abutments at each end shaped as a curved arc. Arch bridges work by transferring the weight of the bridge and its load partially into horizontally thrust, restrained by the abutments at either side. An example of this is a stone arch bridge. A suspension bridge is a type of bridge in which the deck is hung below suspension cables and vertical suspenders. An example of this is the Capilano suspension bridge. A cantilever bridge is a bridge using cantilevers, which are structures that project horizontally into space supported on only one end. An example of this would be the Niagara cantilever. A beam bridge is the most simple structural form, being supported by an abutment at each end of the bridge deck. An example of a beam bridge would be the Chesapeake Bay Bridge. The four components that act on your bridge are tension, torsion, compression, and shear. Tension is the act of stressing or straining. Torsion is the act of twisting or being twisted. Compression is the action of compressing or being compressed. Shear is to remove by cutting or clipping. When I tested the bridge, the first thing I had to do was weigh it in grams. Then we had to attach our bridge to a piece of wood connected to a scale. The scale would measure the load on which the bridge could hold on a 10-to-1 ratio. Then we broke the bridge and converted this number into grams. Then we took this number and divided by the weight of our bridge to find our bridge efficiency. The first step we took when designing our bridge was to create a model in Vectorworks. We then transferred our model to West Point Build Bridge Designer. We then were able to test where the bridge's strong and weak points were. After seeing what parts of the bridge needed to be thicker or stronger, we would then go back onto Vectorworks and change the design. The design would then be drawn to scale, so all you had to do was print it out and cut the wood exactly how it was to create our model of a bridge. If I could do my bridge over again, I would recommend that you make the bottom very strong, because that is where my bridge broke. If the bottom was stronger on my bridge, then my bridge would have held a lot more weight than it did. A deck roadway is hung below suspension cables on vertical suspenders. You can spot the differences because a deck roadway will always be hung from suspended cables and will be on a suspension bridge. A through roadway is when the road members are both above and below the roadbed. It is called through truss. You can spot this because it has a roadbed above and below the road. A pony roadway is where the sides extend above the roadbed but are not connected. Trusses are a framework typically consisting of rafters, posts, and structures supporting a roof, bridge, or other structure. The Howe truss was designed by William Howe in 1804. It used mostly wood and was suitable for longer spans than a Pratt truss. It was one of the best designs for railroad bridges during its time. When the load is centered on the bridge, the forces are much stronger on the internal truss members than when their load is spread out. The Warren truss was designed by James Warren in 1848. It uses equilateral triangles to spread out the loads on the bridge. The Pratt truss was designed by Thomas and Caleb Pratt in 1844. It was made mostly of iron and was used for railroad bridges. The center load on the bridge was the main force, and it's applied on the internal members of the bridge. You can tell the differences between these three bridges because they are all designed differently so that the compression and tension is exerted differently and is put on different areas of the bridge.